Ziua tuturor, deoarece webinarul va fi în engleză, vă contează și eu în engleză. Good morning, everyone. I'm Alexandru Savinov from DAAC Digital. We are a group of IT companies with businesses in Moldova, Uzbekistan, and Romania. It's a pleasure to welcome you all to our webinar today, where we'll talk about how robots are changing the way we work. Today, we are joined by Daniel Schäfer from DAHL Robotics, a pioneer in collaborative robotics and part of the United Robotics Group. Daniel, with his extensive experience in automation and integration and his role in advancing autonomous mobile robots and cobots, will share valuable insights into the world of advanced intralogistics. So our goal is to show you how these robotic solution can make businesses more efficient and safe. We'll share real-life cases and look forward to your participation. You can ask a question anytime in the chat or the Q&A section. You can do it in English, Romanian, or Russian. We will translate them to Daniel. Thanks for joining us, and let's learn together. Daniel, you have the floor.
Okay. Thank you, Alex, for this nice introduction. So my name is Daniel Schäfer. I work as a sales engineer here on mobile robots. We go together to this webinar today, and we are really delighted for everyone that listened to us, and we are going to this agenda today together. So the opening is already done. Thank you, Alexander, for this. In the second part, I will show you some of our automation solutions from our company, Mobile Robots. This will last about not 30 minutes, I think about 45 minutes. And after that, we will see some performance cases and practical applications that we have already done. I think that should be like the most interesting part for you, because there you can see how we really work and how we can make your business efficiently with our robot solutions. After that, we have enough time for a Q&A session. So every questions that you have in mind, please write it down and we can discuss about it later in detail. Also, you will get the presentation afterwards from Alexander, and you will have all the presentation and also my contact details. So the first question is, what is Mobile Robots? Mobile Robots is part of the United Robotics Group, what is a company of companies for robotics and also for automation. In our company, we have very different entities that have responsibility for different robot applications. We have some companies that have the focus on humanoid robotics. We have some companies that had their focus on service robotics or industrial robotics in general. And we, from Mobile Robots, we are part of it, and we have our focus on collaborative robotics and autonomous intralogistics with mobile robots. Over these company groups, there is the RAK Foundation. This is a German foundation that invests in future-based technologies like robotics, and all the profit from the companies goes back to the RAK Stiftung. The RAK Stiftung used this money to do social projects in Germany. For example, there are very big damages in the German environment, especially in the Ruhr area from the mining industry from the last century. And the RAK Stiftung, RAK Foundation is using this money to fix this problem. So this is something what lets me sleep very well in the night. So as I told you, we have our focus on mobile robots and on collaborative robotics, and these are our main focuses. Meanwhile, the first is the mobile robots. We have two big differences with mobile robots. The one are the AGVs, and the other one are the AMRs. We will talk about this later. What this difference means. The second one are our cobot palletizing solutions. I think maybe one or some of you may recognize these little robots. These are collaborative robotics, and we use this for our palletizing solutions. So the founder of our company, DAHL, was one of the first integrator of this collaborative robotics in the German environment back in 2009. And the third part of our business are cobot applications in general. For example, for other applications. And you see here some of the products from our preferred partner, Universal Robots for robotics. So we are a total solution provider. What does this mean? Or why should you use an integrator instead of a manufacturer? When you are searching on the internet for robotics or collaborative robotics or autonomous intralogistic, you will find all these manufacturers or even more. So, but what does this mean? So, for example, if you have a use case and you are looking for a solution and you will contact the manufacturer, the problem is every manufacturer will tell you, okay, I have the best product in the world. But it isn't that easy. So there are some really good products, but not every product is usable for every use case. And that is where we come into the game. We are an integrated and total solution provider. So first step is that we do a consulting. We look at the use case and see, okay, what is the status quo and what do we need to make a total solution and automate the intralogistic that it works really well for the customer. The good thing is that we are independent from the manufacturers. That means for us, it doesn't matter what system we use. For us, it only matters that the use case works for the customer. So in the first step, we do the consulting and show different systems that could work. And then we build a total solution with a conceptual design and we check in the feasibility. So if we have developed this with the customer, we do a test installation. That could be 1 week, but this could be also several months to see, okay, how does this solution really works in the customer's environment and how do the employees react to it? When we have and tested the solution and it works also well, we do the commissioning of the system and develop it. For example, you need to connect it to an MIS system, or we do all the IT integration or the integration to other machines or conveyors, for example. With this always comes the CE and the safety documentation. So we are from Germany, we are the country of the big rules. So this is a very important part here. But we are not finished then. After that, there comes the after sales service. That means we have own service and maintenance contract as our employees come to the customer site and take care of the systems and also train the employees of our customers that they are able to work with the robots on their own and not that they are a little more independent from us. So I told you there are different AMR or mobile robot systems, and there are big differences in the system navigation. The first, what you see here is really old school. This is the navigation with magnetic stripes or glued lines. So this is like the first mobile robots in the past. For example, the first mobile robots was in the 80s or the 70s even, and they worked with magnetic stripes or glued lines that they are followed. But it is not really state of the art anymore. Nowadays, most of the systems work with safety laser scanners and LiDAR sensors. So the safety laser scanners are, we need to detect all the obstacles and they are responsible for the human safety. That means before we commission a system or when we commission a system, we have to map all the environment. That means that we drive with the system to the environment, to the floor and create a virtual map. And then after that, when we drive our missions and do our work, the system recognizes all the obstacles and compare it every time with the map that is already installed on the robot system. Additionally to that, we have LiDAR sensors. As you can imagine, all these safety laser scanners, they are on the ground level, about 10 or 20 centimeters above the floor. But that is not a stable environment because there should be or could be pallets that are not already not every time there or persons that are walking by. So the map is changing day by day. When you have a LiDAR sensor on top, this is very good for stable navigation because it's above 2 meters from the height, and on this height you have a very stable environment because we are looking on walls, we are looking on shelves, and I think the most of our customers doesn't change the walls every day. So this is very good for a stable environment. If this is not enough, we can also work with reflectors on top to make the navigation more stable. As I told you before, there are two big differences in mobile robots. The one are the AGVs. In English, it is called automatic guided vehicles. And the other ones are the AMRs that are called autonomous mobile robots. And I will show you now what are the differences. So an AGV, as the name called, is a guided vehicle. That means it is guided by these lines. In the past, it was, as I showed you on the slide before, with glued lines or magnetic lines on the floor. And nowadays, these lines are vertically. That means that we have a goal, we have a start and a goal, and we follow this line till we reach our goal. So, but what does happen when there's an obstacle? For example, a pallet or a person. The system goes and detects with the sensors the pallet, the obstacle, and will stop. And it will stop until the obstacle is out of the way. The advantage is that we have a high availability and a very predictable behavior and reproducible cycle times, because we know every time, okay, the system will go this way, and also the employees will know, okay, this is the way for the systems. The disadvantage is that we need free travel paths. So when we have an environment where there are many obstacles in the way, this might be not the right solution. So on the other hand, we have the AMRs. As you can see here, we are only looking from this point. We have a start point A and the finish point B. And the line is not strict. So when there is nothing in the way, we would choose the quickest path or the quickest way. But example, when there's an obstacle, the sensors would detect it and then planning a way around the obstacles by itself. So we can avoid the obstacle and we are finishing the goal or the mission. The advantages is that the environment influences are compensated, and also an adjustment to the hall layout usually do not require any reworking, because the system can plan this path by its own. The disadvantage is, as you can imagine, if we want to avoid an obstacle, we need much space here. That means if the way, for example, would be like this line, we don't have enough space, then we can't avoid the obstacle. This means you need bigger paths when you have an AMR. So now we will come to parts of our portfolio. We have built like a standard portfolio with systems that are proven and that we use very often. And now you see different of these systems. The first is like a really low cost automation solution. It is for very small payloads, 20 kilograms. The new ones, there's a new version that can handle up to 35 kilograms. And we use really loose glued lines on the floor. That means it is not very flexible, but for some use cases, when you don't have very much weight and you have every time you need only the same paths to go, then this could be a really good solution, and it is very, very stable in the navigation. The second one is an AMR, an autonomous mobile robot, what I told you before. And MIR is the manufacturer, it's the name here. Maybe some of you recognize it because they are was like the first manufacturer that developed the modern mobile robots as we know it now. This is a platform AGV. It has a payload up to 250 kilogram. And we have many functions on this because this is a platform and you can do above it more or less whatever you want. So that means this robot is like a chameleon. We can use it for many different use cases. I will show you the video. I hope you hear. Okay, there's no sound behind it, no problem. This is one use case, for example, one tool is we call a shelf carrier. You can do a shelf on it and you can transport this. It don't require very much space. We see what the robot looks like from the inside. Here, this is the safety field. Here, the laser scanners. Here is a 3D camera for safety as well. So, and they have also light indication when it turns, for example. You can do a cobot on top. You can do whatever you want on top. This is a really big advantage. So for this robot, there is like an ecosystem of equipment. We have some equipment that we build by our own. When we need a special solution, we do it completely by our own, but there is one manufacturer, the name is called ROIC. It's also from Denmark, like MIR, and they have built like standardized ecosystem with many functions. The most important are the conveyor modules. For example, when you want to transport goods from one conveyor to another, or these cart modules, as we've seen before in the video, and you can build up to this cart whatever you want. It could be a shelf, or any other structure. And there are some lifting modules too, and some other accessories as well. And I will show you some of it now.
Just a little bit quieter, please.
Was there a question?
Just a little bit quieter. It is
okay.
So loud, the music. Thanks.
We can put up the cart and drive it to a goal. After that, it is a really cool human-robot connection because the same cart can be used by a worker as well. So let's see now. Okay. So the next product or next system is Robotize. It's one of our favorite products. It is for pallet transport, and it's also like the system before. It's also an AMR. That means it can avoid obstacles. We have different products. We can do payloads up to 1.2 tons, and it can be used for pallets as Euro pallets, industrial pallets, special pallets, and special load carriers even. We have a very big customer, Class Industrietechnik, and we will see use case later from it. But now here I present you this robot. It's an under-rider vehicle. That means every time when you want to pick up a pallet, we need this station because we have to ride under the pallet. What's also, okay, I started again, sorry. What is also very cool on this robots, we have on the one hand, we have the safety laser scanners for the human safety, but on the other hand, what you here see is a safety bumper for the foot. So that means we have two different safety features, and this requires, this is very good for the safety field. Every robot, when it drives, has a virtual safety field around it. And because we have this safety function, it could be very small. So this is very good when we don't have very much space, because it reduces the footprint in the sensor field of the system. You can see here, it's very flexible. It can turn about its own axis. There's a question from Ruslan. Somebody picked up his hand.
Yes. Ruslan, dacă aveți întrebare, puteți să faceți unmute sau
The sound?
scrieți întrebarea.
I think there is no sound behind this video.
There is no sound.
Okay. Was that everything? Okay, I will do it again.
Ok, Ruslan, deci aveți posibilitatea să adresați întrebarea sau să o scrieți în chat. Mersi.
Okay. So
We can continue.
we will come. Is there any question, or can I continue?
Yes, you can continue.
Okay, perfect. So this is the next product. It's the Nipper. It is one of the first AGVs that we used. AGV means it is an automatic guided vehicle. It follows lines. And this is when you want to transport pallets and you don't want to have these stations everywhere. So you can pick up the pallet from the floor. They have different products. The Nipper pallet truck, what you see here, is one of the first products. And now you will see it later on the video. There's a new AGV. It's called Nipper V4 that has a payload up to 1.2 tons. And there's a very cool function. For example, it can drive omnidirectional. That means it can forwards, backwards, and sidewards as well. This system is very small. It has a very small footprint, and we like to use it when we don't have much space in our environment. I will show you now how it will work. We have here forklift scanners and even barcode scanners here. And as you can see, we don't need much space around the vehicle. The old one has a speed of 1 meter per second, but the new one can also drive 1.5 meters per second. Here are the safety laser scanners behind between the forks, and we have blue spot as well. System, we have only a small lift. It's about 150 millimeters. That means that is only for floor to floor transport, or for example, you can transport it to a conveyor that is near to the ground. Yeah, pleasure. So this was on this year's Logimat. Here you see myself with the sales manager of NIPA, Willem Lepelas, and here behind him you see the new NIPA version 4. It has a very cool new design and also now a LiDAR sensor on top for very stable navigation, as I told you, because you can see on the bottom floor and in this height as well. But you will see later on this video the driving functionalities, which are pretty cool and a very big advantage. To see the new NIPA running on your booth. What was the motivation behind this new development?
Well, thanks for having me. And the motivation is to have the perfect connection in a production environment.
So this is what I mean.
So what we redeveloped is an AGV that can fit into any existing production process. It has an omnidirectional driving, a wireless charging, and it has the lowest forks on the market. So
what you also see
we
here,
can cope.
You have here LED lights that can react to the environment. That means it is an AGV. That means that it will stop when an obstacle is in the way. And with these lights here, it signals to the workers or the employees what status is it. When it is green, then it means, okay, the way is clear, I can drive. For example, when some person would go here, this light would follow the person and detects it. And that would say, okay, for example, it would get red and stop and tell the person, okay, you are too near, I can't drive anymore. And when the person goes away, the light changes and can drive. So this is very good for the acceptance for the employees because they know what the system wants, more or less.
With any type of pallet.
So maybe you ask yourself, okay, what if when I have pallets, but I don't want it transported only from ground to ground, I need to pick it up in a shelf. For this use case, we have the Vevo AGV pallet mover. It is one of our favorite systems as well. As you can see here, we have safety laser scanners. Here we have safety laser scanners between the forks, and we have here on top LiDAR sensor as well, and also here light and the blue spot. So we have a really good safety field and a really stable navigation. Also, it has a high payload from 1.3 tons, and there are different systems. The pallet mover standard can reach a height from 1.3 meters, and the pallet mover stacker can lift the height to 2.5 meters. And there's also a stainless steel version, for example, for the food industry or the pharma industry. But it requires a little bit more space because it is bigger, for example, like the Nipper. Here you see the first shots of our customer Mon Media. There we implemented 12 of the systems now. So the lift is also able to, for example, bring goods to a conveyor that is on a very good height, as you can see here. So here's the stainless steel version for food industry or pharma industry. So, and we can do like, special design if it's needed for the customer. So as we are not only a system provider, we are an integrator. That means that we are always looking for good solutions for the customer and especially for software, because every system has its own software, and we wanted to create human robot interface. We created and developed a software by our own for a big customer, and we now do it on other projects as well. We call it mission control. On this software, you have the full insight about every mission, and we have a dashboard. You can use it with different users, and also you can use this software not only for one system, but for several other systems. That means when you have different systems in your company and in your environment, you can control everything with this software. It's very easy to use for the worker and the employees, and you can create new missions within seconds. You can chat between persons and devices. You see this the loading capacity of the system here as well every time, and you can track the system where it is. This is something what we are working really hard on. Okay, this was more or less most of our mobile robots. As I told you, that is like our standard portfolio, but we have several other projects where we use other robots as well. So what we told you, we are independent from the manufacturers. That means if we have a use case that requires other robots, we will use other robots to make a perfect solution for the customer. Now we come to our second big business case, and that is the cobot palletizing. The palletizing was one of the first use cases that we had with collaborative robotics, and within the years we developed a very good standard solution for the different palletizings. We have different sizes. This is the medium one with a UR10E from Universal Robots. It can have a payload up to 12.5 kilograms, and we can palletize Euro pallets with it. Then we have the model palletizing L with either a Dosan cobot or the Universal Robots UR20, and the payload of up to 20 kilograms. And also we are not only able to palletize Euro pallets, we can palletize bigger pallets like industrial pallets as well. And now there is the newest development from Universal Robots, the UR30, and now we are able to palletize payloads up to 30 kilograms. And what makes this solution so special? I think the most of you know the normal industrial robotics, for example, from the automotive industry, and they are always really big and they need really closed safety fields. There are big fences or sensors around it to make it safe. This solution is not only flexible because you can change the location within minutes, it is mobile, but also it is safe in itself. That means you can put this solution in your environment without any fence or other safety function like a laser scanner, because all the safety and technology is in the cobot itself and also in our own developed gripper. This is a special vacuum gripper. This has sensors inside. And for example, when the robot is moving and there comes a person and strikes his head or his hand in the way, the cobot will stop immediately without hurting anyone. And now, so we can sell a safe solution with CE without any fence, and that makes it very, very flexible. It's a high advantage. You will see some videos of it now. Here I have the video of our medium kit with the UR10E up to 12.5 kilograms. And here we'll see how it works. So the specific or most of the use cases you see two pallet stations here is that you have like a production conveyor with finished goods, and then you want a continuous workflow. In the past, when you have the production, there might be like at least one person per shift that has to carry these boxes all day long to put it on the pallets. That isn't good for the worker, and it isn't good for the efficiency and for money as well. And with this solution, we built a continuous workflow. That means the robot is palletizing the packages or makes the pattern on one pallet. When it's finished, there's a light signal to change the pallet. And in the time where the pallet is changed, the cobot can pallet the other side. So you have a continuous workflow without any interruption. And in the best case, an AGV is connected to this pallet and bring it to the goal automatically. We have the system there as well, so we can palletize to a height of 2.2 meters or even more.
We cannot really hear you when it's on top of the video.
Please?
We cannot really hear you when you speak on top of the video.
Okay, okay. Okay, thanks for the information. So here we'll see the own palletizing software that we developed. It comes with every palletizer, but we will see about this later on detail. So this was the medium kit, and now we have also a video for the bigger cobot, the 20 kilogram. Here we have a Dosan cobot on top, but we usually use the universal robots. This is a special conveyor that we built. It is very special because it has rolls on the surface. That means for this solution, we need to grip 2 packages at once. We have special grippers already built that can pick up to, I don't know, 6 or 8 boxes. And then it means when the products come from the conveyor, we need to stop it here. For example, when you don't have a carton, you can have the surface could be a foil. And when we stop it and the conveyor turns or keeps turning, then you could hurt the surface. For this reason, we have little rolls here. So there is no pressure at all on the product, and we can stop it without any damage on it. We have sensors here inside of the construction that we can detect the pallet. That means, if, for example, an employee doesn't pick up or put the pallet in the right position, we would detect it. So this is very safe that we don't make fail the system. Yeah. This is what I called you the safety function. So if anyone comes and goes in the way of the cobot, it stops immediately without hurting anyone, and that is the reason why we can sell it as a safe system without any fence. So now we come to the palletizing software that we developed. We call it Logisort, and it is really easy to use. It always comes with our system, and you can create new patterns into minutes. For example, we have some customers, they have several of different patterns, like, I don't know, like 100 or everything, and they have every time or they can have new patterns within some days. And they are with the software, it's really easy with drag and drop. Then they can create these patterns within minutes. First, you create the boxes, the dimensions, then you install the orientation, and then you have a new pattern, and then you can use this data with a USB stick, put it on the palletizer, and then you can use this pattern very fast. There's some own development by us. Okay, this was more or less the presentation of our portfolio. And now we will come to our performance cases. Two of them are filmed by ourselves. The biggest one, or the most important one, is the proof of performance on Class Industrietechnik. It's a very big customer from us, and here on this use case you will see how we really start every project and what is possible with the time. And it is about 13 minutes. When this video films, I will stop speaking and let you enjoy the video. After that, we will see a use case from the printing industry, the Bertelsmann Verlag, with our Vevo systems that I showed you before. This is only a teaser because the marketing is still in the working. The video will be finished early in 2024. My colleague Manuel is working really hard on it. And then we have also some performance cases from our partner MIR, because they have a very good marketing. And this is from the automotive, mechanical engineering and retail goods, from Eaton and from Forvia, and they are in the Czech Republic and in Romania. So I will start the video now.
Just a second. I propose to make it more dynamic, not to make the Q&A session in the end. We have now a question from Mikhail, who's asking if the robot that palletizes have different kind of boxes on the same pallet.
Yes, this is different kind of boxes. Yeah, it depends on the boxes. That means that we have to detect boxes with sensors, but it is possible. Yeah.
So
it is
with an additional camera that sees the size of the boxes, and or how do we do it?
It depends on the use case. We can use a vision camera, but for example, for some use cases, we can use a sensor as well that detects the length of the product, for example. It depends on the use case, but it is possible. For this reason, we should look at the use case and at the boxes in general.
Mikhail, if that's all, or maybe if you have additional question, feel free, or you can ask your question now.
In case we are doing picking, so we are picking the
Mikhail, just a little bit louder, please.
We are picking the different kind of boxes, smallest one and biggest one. So the robot, could we implement this solution in the production using after the picking to be palletized the different kind of boxes on the same pallet and should be prepared for delivery?
So I don't understand you 100% correctly. Could you please repeat it? It was a little bit a little bit louder, please. I can't hear it. Or maybe we can discuss it later, and you can write your message in the chat, because right now I only see my presentation and I don't see the chat.
Okay, Mikhail, you can reconnect, or we can discuss it later. Okay, thank you. Thank you.
Okay, thank you very much. So I hope this works now. 1 second. Okay. You see the video?
Yes.
So now I will stop talking. I hope you hear everything. Please enjoy the
We can
video.
hear with your comments as well, because it is now the perfect volume. It's okay.
Is it
If
too
you
loud?
have some insights about this, you can add them on top.
Okay.
Claas Industrietechnik in Paderborn, Germany is a center of technical innovation. An impressive history unfolds in the factory halls that is inextricably linked with the renowned parent company, the agricultural machinery manufacturer of the same name. Since 1957, Claas Industrietechnik has been driving development in the areas of drive technology and hydraulics, with a dedicated workforce of more than 600 employees. For Claas machines, as well as external customers. A particularly innovative product line are the continuously variable transmission variants for Claas tractors. The components required for this are processed with maximum precision in 16 fully automated processing stations. The employees, trained to automotive industry standards, assemble around 700 components into one drive unit. To provide them with the best possible support, the company has always relied on appropriate first-class technological solutions in production. With the goal of increasing the efficiency of internal transports, more than 90 kilometers per day, Claas Industrietechnik has been trusting in the AMR and AGV integrator MR mobile robots and the autonomous transport system GoPal from the Danish manufacturer Robotica since 2020. So we started in 2020 with Claas and first made a test position there. One robot, one charging station, 4 pallet stations. With these components, we have first mapped a basic process to find out whether the unit can work in this environment. Because the environment was quite demanding, attributable to oil from the processing machines, and because of metal chips as well lying on the path, we have had difficult ground requirements in the sense of very uneven ground. This resulted in many blows that the device had to cope with. We were faced with narrow driveways and a lot of passenger and device traffic. After 2 months of testing, we were then able to determine that the robotized system can cope with these difficult requirements. In spite of the minimal space available, the robot works at its lowest limit. We have really created a lot of storage space here and a very fluid workflow for the employees. The robot we tested with was then replaced by the final model that Claas intended to use, a robotized GoPal E24. This type is able to handle payloads of up to 1 ton. With this first step, the initial process was finally implemented. This means that we no longer had 4 stations with which we only tested, but we actually equipped several processing centers and set up several stations in front of the washing plant in order to carry out this process of delivery and return of the goods carriers to be completely automated. As of today, processes have been introduced to transport goods away, which previously had stood in the production area waiting for the next machining step. These parts are now transported to the high bay warehouse by the robots and recollected from there when needed again. This makes the manufacturing area much tidier. You have more space and you can work more cleanly. For Claas, advantages of the robotized system are actually many-fold, depending on the process we focus on. It has been shown that the system is very well suited to automating a process that previously had been very strenuous for workers. As a result, heavy parts are no longer carried manually from the machining centers to the washing plant, and the goods carriers back again. We completely automated this by the robotized system, resulting in corresponding capacities being freed up among the staff. Inconvenient processes, where men only walked through the production, have been eliminated and could be completely taken over by the robotized units. Regarding the selection of the autonomous system, the choice has fallen on Robotize, since it is very flexible. In this environment, an AGV, for example, would not have been successful, since Claas is a company that has grown, a production environment that has grown. This means you have no wide corridors that are always free, that always look the same. This is why a flexible system is needed that can avoid obstacles and drive around them. A system which can also choose alternative routes when a track is completely blocked. Another advantage of the robotized system is the item software updates. In this case, we have a very flexible manufacturer who accepts our suggestions for improvement and who delivers software updates which are at our free disposal. More functions are being added, and the customer's requirements were and still are specifically addressed. Different features were introduced especially for this customer, but they also bring added value across the entire fleet. This means such developments are not only customer-specific, but also bring added value again for each user of the system. As we told, Claas has started with one device, and then we went one step at a time here together with the customer. In this process, the system was not only expanded with robotized components, but additional modules were also combined with it. This means not only were more and more machining centers integrated, but a washing system was also installed that had been specially designed for interactions with the robotized system. As a result, the robots can now enter this washing plant automatically. The parts are removed from the carrier and fed automatically into this plant. The robot takes the goods carrier out again and puts it down so that after the cycle, a worker can put up the empty carriers. And then these good carriers are returned to the machining center. With the insertion of the new washing plant, a completely new warehouse concept was also directly integrated. We are talking about this large area of stations you see here. The process is that the washed parts are taken out of the plant with a crane and, as it is shown here, are put into the mesh boxes. Once the boxes are full, they are moved to the warehouse. These mesh boxes, that's the key here. They always have to be positioned the right way around. Therefore, they are analyzed by a camera to verify whether the single box is empty or full, and if its alignment is correct. Depending on its status, the mesh boxes are then correctly sorted by the robotized system and reintroduced into the process cycle again. We have seen that the employees were always positive about the replacement of the manual processes. It's nice to see all the interactions, not just between employees and AMRs, which is kept very simple indeed. We use manual call buttons. The operator just pushes the button, and then everything is done for him. At the same time, he also has a status display. This is partly solved by digital means, by the use of tablets or screens, as we can shift this status functionality with more complexity to the devices mentioned. In addition, we ensure the interaction of the AMR system with everything that is important in the manufacturing environment. The simplest example is the roller doors. The AMRs pass through a large number of roller shutters at Claas, some of which are sensor controlled, but some of which are actively opened by the unit. Here we benefit from the advantage of having simple I/O boxes on board. These are very simple small boxes which are fully integrated into the system. You can directly connect the roller gates, configure them, and they are included in the system. For example, in the storage area, we control LEDs via these I/O boxes. The idea is to signal directly to the employees, there are pallets here that now have to be picked up and taken to the high bay warehouse. This means also visual indications to trigger interactions with staff can be easily implemented. A very important aspect is also the topic of security, especially on the main corridor, where our robots are traveling up to 2 meters per second. Through a system that integrates not only our AMRs, but also the traveling forklifts, we project visual markings directly onto the intersection ground. No matter if a robot is coming now or a forklift approaches, people are warned visually. Another autonomous transport that has been implemented with our support is a metal swarf removal. In this case, two robotized units are working in combination in order to remove full chip containers from the machining centers and reposition an empty container. A special requirement, namely that everything has to fit into the smallest space, which is just typical for the brownfield, where we can't reschedule, is particularly evident at the parts washing plant. Although this plant was newly installed, it still had to fit into the tightest of spaces. About 70% of all transports at Claas Industrietechniek are led to this new washing plant, meaning we have a real challenge here regarding traffic. This is because the transports usually do not arrive in an orderly manner and with a certain time lag. But, especially after the break, 3 or 4 robots regularly gather in front of the washing plant. This had to be solved. Indeed, we have an AMR system here that finds its own way, but even this feature is ultimately limited. Consequently, as the responsible integrator, we had to work very precisely and take many details into account in order to finally achieve a good workflow here and to ensure a fine processing of all individual missions. And this is exactly what we have managed to do. As of today, the total system has grown to 6 robots. We have approximately 150 stations, and we are currently working on an expansion. For example, with a pallet magazine that is to be integrated. The robot fleet currently travels more than 90 kilometers a day, fulfilling about 500 single missions. That means that we are proud of a really productive and effective system here.
So,
That is an impressive case. Congrats on
Please?
that. It is an
Impressive
impressive case, yes.
yeah, we are glad to hear this. Yeah, we are really proud of it. Yeah. So the second one, this is also a very impressive case, or maybe an even more impressive case, but it is not fully finished. We only have a teaser here, but it will be finished in early 2024. And if there some of you are interested to get it, we will can give it to you as it is finished. We now see the teaser here. And it is at our German customer, the Bertelsmann Verlag. It is one of the biggest numbers in the printing industry. And here we installed the Vevo system. And yeah, we are really proud of this customer, and the customer is really happy with this solution as well. What you can see here, this is an AGV. That means what I explained before, we only follow the line. But that doesn't mean that this should be a problem. When the driveway is clear, we are able to drive the same ways as the humans with other forklifts or other systems. So it has a very good machine-human connection. and it is very stable in the navigation, even if there are other vehicles on the roads and other traffic. I will be happy when this if this use case is finished and this performance case is finished, and I will show you the full video then. So now we come to the performance cases of our partner MIR. It is not filmed by ourselves, but we already done many projects with these robots and many use cases of this. Maybe it should be interesting because it is in Eastern Europe too. This is Forvia, that are based in Czech Republic, and Eaton is based in Romania as well. And now we see the performance cases of our partner MIR.
Forvia is one of the world's largest automotive technology groups, and 1 in 2 vehicles worldwide is equipped with Forvia products.
In Forvia exhaust system plant in Písek, we are producing exhaust systems, which are for our main customers. This is Daimler, PSA, and Volvo. I would start from historical point of view. Something like 5-6 years ago, we had on the shop floor forklifts, stackers, and all this manual guided equipment with people. Of course, we faced a lot of risk of accidents, and we decided to switch to automation. We choose MIR robots, and we installed 14 robots, which will secure both safety and efficiency on the shop floor. The mobile robots MIR are also used in other countries. Aside the Czech Republic, we have it in France, we have it in Italy, we have it in Portugal.
Forvia uses its fleet of MIR robots to automate several processes within production and logistics. The 7 MIR 250 robots are used to automate the transportation of monoliths from the monocage to the assembly of work-in-progress parts. The robots transport the monoliths from one building through a long, fully covered outdoor hallway to the production. Here, gravity systems deliver the monoliths and pick up empty packaging to take back to the warehouse area. Forvia uses 7 MIR heavy-duty robots to automate the transportation of finished goods from the production to be picked up in the logistics area. The robots are automatically summoned when a pallet is ready to be picked up via a sensor system, and it connects with the custom automated racks that load the robots. When the robot has delivered a full pallet, it will pick up an empty pallet and bring it back to the production for a fully automated workflow.
Then we have one point which we connect also between the assembly line and the strapping machine, which is another step of digitalization in this plant, which is again decreasing the work content of our workers in plant.
Every day we are getting stronger and stronger with the technology, and I can remember when I arrived 2 years ago here, it was really a mystery for me, and now it's more easy for me, totally easy. I know how they are working, I know how to resolve some problem, etc.
In our processes, we are sharing the same area with other equipment, with people also serving the lines, and robots MIR are fitting the most the environment which we have on our shop floor inside FCM Forvia. I think people and robots can align together, as the robots are smart in a way that they are recognizing the people on the shop floor, so there is no problem to stop or bypass people which are going around. MIR fleet is used for organizations of missions, and next to this fleet from MIR robots, we also use our internal script, which is helping to organize the flow on the lines and between the lines. Next goal for us is to integrate MIR fleet into ERP system Forvia. Mobile robots MIR are working in our plant 24/7, so it means we are covering 3 shifts per day with these applications. MIR we choose as there is the complexity of the process setup, like a Wi-Fi connectivity map running in fleet. Then we have quite a reasonable payback of 2 years. which is giving us opportunity to get validate the investment. MIR robots help us to increase productivity, and we have good experience. We got a lot of support for integration across Europe, and a big potential for wide usage in our operations.
Okay, this was the performance case at Forvia. Now we have one last from Ethan that are from the retail good.
Titan is a global power management company. Our plant is located in Arad, Romania, and manufactures products for our life safety business unit. We implement MIR robots to optimize intralogistic processes and safety. We wanted to relieve the workforce and shift employees to more value-add tasks, like complex assemblies. MIR robots help us also to optimize processes in view of workforce shortages. MIR robots work 6 days per week, operating in 2-shift systems. They transfer more than 100 pallets every day. The MIR 500 perform over 100 missions. During each mission, they cover more than 120 meters, marking a total distance of around 12 kilometers per day. The MIR 200 execute more than 120 missions, covering a total of 25 kilometers. This shows the scale of the optimization in our intralogistic processes. Before we implement AMRs, our employees transport materials using manual forklifts. This took a lot of time, especially between shifts, when assembly lines had to be prepared for the next production orders.
Our fleet contains 5 MIR robots, 2 MIR 500, 2 MIR 200, and 1 MIR 250. The MIR 500 operates 52 assembly lines, and the MIR 200 operates Kanban's locations. The MIR 500 robots drive to the rack, lift the pallets, and carry them to the docking station. As for the MIR 200, first, the line feeder gives information about the missing material. The warehouse operator picks the material from the shelf, loads it onto the MIR 200, and selects one of the missions. The robot signals with a sound that it has arrived. The line feeder picks up the load, and the MIR returns to the charging dock.
We are the first Titan plant to optimize intralogistic operations with the help of MIR AMRs. I believe our experience will inspire and encourage other companies, factories that want to improve their performances. We are expanding our profile and building a new surface mount technology location. The next robots operating in our facility will be MIR 250, one of which we already have. The robots will get to the door, automatically open it, drive up, and pick up electronic components from dedicated racks. Each rack from the docking station has a presence sensor. The scope or the role of this sensor is to tell to the AMR robot that the place is empty or not, so that the robot can place the pallet. The AMR, which is back, is staying now and scanning the empty position. If one of the position is filled with pallet, he will detect it and he will not place the pallet there.
Since the implementation of the MIR robots, we have less work related to manual handling and simply moving around the factory. The collaboration with the robots is smooth, and now I spend more time on controlling the process and the assembly operations. In addition, I have more time for personal development. And thanks to the MIR robots, the efficiency of our operations has increased, and we've improved the quality of our work.
Okay, this was Ethan from the retail industry, and this were our performance cases. So now we have time for the Q&A session, but maybe I will stop the presentation now because it is finished, And when I stop, then can I see your faces and I can see the chat as well. So that was from my side. Thank you very much for your attention, and I will stop the presentation now.
Yeah, thank you, Daniel. If there are any questions, you can raise your hands, you can write them in the chat. If not, in any case, Daniel, I thank you very much. What I wanted to mention for everybody, we are partners with mobile robots, with DAHL Automations. Every project that we will do together. We have engineers that will assist here in Moldova, in Uzbekistan, in Romania. And we will take advantage of in full of the all the knowledge that mobile robots have in their projects. And regarding our today's webinar, we will wrap it up. The presentation that was on screen, we will send it to everybody who registered to this webinar. And yeah, if you have any question, you can address them now, or we can continue in emails. Daniel, maybe you can put on screen your contact informations.
Yeah.
And our information is publicly available. You can write to sales@dsi.md or write on our page. There is a place where you can send your requests.
Do you see the contact details here?
Yeah, they are.
Okay. And it's in the presentation as well, so we'll get it right afterwards. So any questions or maybe a little feedback from your side, from the listeners?
The attendees are shy today. Okay, maybe it's something new. It's something that we thought it was from the future, but now it is in production in a lot of places. So I encourage you to take a look, to make us some requests. Maybe these solutions are fitted to your processes, and we will try to get a good offer for you. Okay, then let's write it.
Maybe additional to this, as I told before, we are a company of companies, and all the solutions that we see now are from ourselves. But if you maybe have use cases for other robotic parts like industrial robotics or humanoid robotics or service robotics, we will work on this with our sister companies. So if you have any use case that requires a robot, please contact us or Alexander, and we will help you to make you a perfect fit for your environment.
Thank you, Daniel. Okay, thank you, everybody, and waiting for some projects together.
Okay. Thank you very much.
Yeah, that's all. Bye.
Bye.